So as we saw on the two graphs that we just graphed, we can have either increasing exponential functions or decreasing exponential functions, which are exponential growth and exponential decay. And whether we have growth or decay depends on the base. So an exponential growth function is in the form f of x equals b to the x power. So b is the base, and in order to be exponential growth, the base has to be greater than 1. So it can be 1.5, 2, 3, 5, any of those for the base. Now, anytime we have an exponential growth function, there is a few specific points that we're going to have, and these are going to be important when we do our transformations. If I have an exponential growth function, we're going to have these 3 points. We're only going to use 3 when we are graphing exponential functions with transformations. I'm going to use -1, 0, and 1 as my x values. If I have a -1, that would be b to the -1 power, which would be a fraction, 1 over b. If I plug in a 0, that would be b to the 0 power, which would just be 1. And if I plug in a 1, we'd have b to the 1 power, which is just b. So if the base is 5, for example, that means we would have the point -1, 1/5, 0, 1, and 1, 5. So the b depends on whatever the base is. So this is a generalization for any type of exponential growth function. Now, what's also true is any type of exponential growth function looks the same. It's going to look like the 2 to the x power that we just graphed. They're all going to have a point at 0, 1. They're going to have a point at -1, 1 over b, so that's going to be a fraction number, and a point at 1b. So, like I said, the actual coordinate point will depend on what the base of b is, but we're always going to have a function that looks like this, an exponential growth function, and it's always going to have a horizontal asymptote. So a couple characteristics that we should recognize here. As I said, this has a horizontal asymptote. It is horizontal, so it is in the form y equals. This one's going to be in the form y equals 0. It's also an increasing function, which is what makes it exponential growth. We also should be able to identify the domain and range. So hopefully we remember a little bit about that. Our domain is the set of inputs or the x values. We can plug in any x values we want. Or if we look at our graph, our domain is -infinity to infinity. And then remember, the range is the set of outputs. Now, the range is not infinite. When we think about the outputs we get, we never get negative outputs because we only get fraction numbers that are closer and closer to 0, but never actually equal to 0. Or if we think of our graph, our lowest to highest, the lowest on the graph is 0, but it's never actually equal to 0. So that's why 0 has a parentheses. So our range is 0 to infinity because the highest is infinity. So that's for an exponential growth function. And this is true no matter what the base is. Now, an exponential decay function is, there's two ways to write an exponential decay function, but usually we'll see it in, it'll look the same. F of x equals b to the x power, but this time b is a number between 0 and 1, meaning that it's a fraction or a decimal. Like we saw when we graphed f of x equals 1/2 to the x power. That's the most common way we can see it. So let's go ahead and write down that information as well. So this function is actually going to include the same points. If I include x values of -1, 0, and 1, if we plug in a -1b to the -1 power, is going to still be 1 over b, but this time b is going to be a fraction. So this is actually going to end up being the reciprocal of b. Now, if we plug in a 0, we still have b to the 0 power, which is just 1. And if I plug in a 1, we have b to the 1 power, but this would be the fraction to the power. So this one is going to be the reciprocal because it's 1 over b. Okay, so that's something to keep in mind when we are graphing this one. All right, so on an exponential decay function, this function is also going to have a point at 0, 1, and a point at 1, 1 over b. Since b is a fraction, this number is going to actually be bigger than a fraction. And if I plug in b, b would be a fraction. So this one is going to look like this, no matter what the base is. So it's still going to have the same shape, even if it has different bases. The bases can be fractions like 1/2 or 3/5 or 0.75, anything that is a number between 0 and 1. All right, so if we look at the characteristics here, notice that this still has the same horizontal asymptote. So even though the b is a fraction, the asymptote is still y equals 0. And the difference, though, is that this one is a decreasing function. However, the domain and range will still be the same. The domain is still -infinity to infinity because we can still plug in any x values we want. It goes infinitely to the left and right. And then the range is still 0 to infinity because the lowest we ever get is 0, but never actually equal to 0. So that's why the 0 here has parentheses. So that's what our exponential growth and exponential decay functions look like. So I'm going to just give you a couple of examples of what those look like, or what the b values can be, so you can understand. So for exponential growth, we said b has to be greater than 1. So that could be something like we just saw, f of x equals 2 to the x power. Or it can be something like f of x equals 5 to the x power. Or it can be f of x equals 1.5 to the x power. Either way, the number, the base, is greater than 1. Where on exponential decay, the number is a fraction. The base is a fraction between 0 and 1. So an example that we already graphed would be f of x equals 1/2 to the x power. Or here's another example. If we have f of x equals 3/5 to the x power, 3/5 is still a decimal or a fraction between 0 and 1. Or even something like f of x equals 0.75 to the x power. That one, 0.75, is still a number between 0 and 1. So that's the difference when we're looking at whether we have growth or decay, is what the base is. So whether the base is a number greater than 1 or a number between 0 and 1. And then another thing to notice here, the x is always just positive x. We also saw one where we had 2 to the negative x power that ended up being decay. We'll see why that happens when we talk about the transformations, which we are going to talk about tomorrow. So for today, we should just be able to identify whether a function is exponential growth or exponential decay by looking at either its equation or looking at its graph.